So we got rectangular and polar coordinates today. We're going to talk about finishing up lesson 14. So let's talk about rectangular coordinates first. So you guys have dealt with rectangular coordinates, and it's a method of using two numbers to locate a point, one indicating the distance left-right from the origin, and the other is the distance up-down from the origin. Essentially, you guys would say, hey, that's just an ordered pair, x comma y, right? So you guys have been doing that all along. So if I say on the bottom here I have -2, 5, you guys could say, hey, I could graph that. It's not a big deal. We've been doing that since probably 6th grade, if not earlier. Go back 2 and up 5. There's your point, right? Well, what we're going to do today is we're going to talk about a slightly different format. And that slightly different format ends up using i's and j's instead of x's and y's. So, where I indicates the x direction, which we normally say the x direction, and j indicates the y direction. Now, it's hard because I'm not able to, on Google Documents, is able to put the little hats on. So I'm going to try to put them on with my program here. So there's a little note there that says to not get confused with I equaling the square root of -1, because we've been dealing with I in that way with imaginary numbers. We place a caret or a hat above the I and the j. And so it looks like a little hat on the i's and j's. So when you see an I hat and j hat, then you know you're talking about rectangular coordinates. And so if you look down below here, that should be a -2 I hat plus 5 j hat. That is the same point as -2, 5. That gets us to the exact same point in space on a two-dimensional plane. Okay? That's rectangular coordinates. So on this slide, we've already plotted -2, 5. We'll just do that real quickly again. But I just want you guys to see that it's easy to plot rectangular because you've been doing it all along. So, -2, 1, 2, 3, 4, 5 is again somewhere up there. But we can see that 3i, and I'm going to make sure I got to put the little hats above, something I couldn't do on the program. Okay? But 3i hat minus 4j hat is really the same as what point? 3, -4. So that's the same point. So you know that you're going +3, 1, 2, 3, and down 4, 1, 2, 3, 4. There's your point. If I'm looking at the last set, what would that point look like? Or let's not write the point. Which way am I going? How far? Going to the left, 1, and up 1. So it's like -1, 1. So it's not that bad, right? These are doable. So polar coordinates, guys, are slightly different setup. It uses a distance, what we're going to call or have seen as a radius, and an angle. So polar coordinates put together a radius and an angle. You're not going directly left or right and then moving up or down. You are going to either walk out a certain distance before you turn a certain degree, or it's easier to go the other way. I'm going to turn while standing in the same spot a certain degree and then walk out. And I'll demonstrate that in a second. And so the form that it looks like is this. radius, it's a U, and angle. This is lesson 14 still. So we're going to have a radius on the outside of this kind of elongated less than symbol with an angle inside. Now there are two types of angles that you have to deal with. You have positive angles and negative angles. If you're talking about a positive angle, you are going to go counterclockwise from the positive x-axis. So, if I draw my axes, I think everybody would agree that this black line now that I changed it to is the positive x-axis. And if I'm going counterclockwise, which way is that? Up or down?
Down.
Counterclockwise. Going up. That is positive. Now, if I'm going in a negative angle, I'm still going to start on that positive x-axis, but I'm going to go clockwise. So you'd go down. So up and down. Maybe put that in parentheses. Just kind of give yourself a note. Think of it, if you're a positive person, you're pretty upbeat, you go up. If you're a negative person, you're going down. I don't know, some way to help you remember that. So, positive angles go in the up direction, negative angles go in the bottom or down direction. So, I tried color coding this a little bit for us, but yeah, it's supposed to be a red box around there. I couldn't change the font color in the text box. So, as we can see, I got the XY axes on there. And what I did with the ones that are outside of the box, it starts at 0 degrees. Now, technically, whether I'm going up or down, if I just said I'm going 0 degrees, I'm staying on the x-axis, right? But if I said I'm going 90 degrees, I go a positive direction to 90 degrees. Yes? Does everybody recognize or remember where 90 degrees are? If I go 180, I go all the way to here. I go another 90, I'm going all the way to there. I'm turning more, right? The more degrees I go, the more I turn. And if I kept on going all the way around, how far would that be? So maybe next to 0, put 360 degrees as well. So technically, I could turn 360 degrees, but it would be like I didn't turn at all, right? Like if I told everybody, okay, everybody, close your eyes, and I spin around, and I'm looking, that's okay, guys, how far did I turn? Half of you guys might say 0 degrees, and the other half might say 360. Or even 720. Because if you don't see me turn, it acts like I didn't, right? Because I'm turning to the exact same spot. Right? If I turn 0 degrees or 360 degrees, I'm still facing the exact same direction. Now, I'm going to erase those to get those out of the way. Because I can do the same thing going backwards. If I say I went negative 90 degrees, I'll use red because we're using the red for those boxes, I'd be going down 90 degrees. Or I can go back anything, really, it doesn't have to be 90s. It could be 20 degrees. It could be 27 degrees, 128 degrees. Okay? But I can go around backwards. And if I completed one revolution backwards, I have just gone a negative 360 degrees, right? So not only can I go forwards 360 degrees, I could turn backwards 360 degrees. You'll never know. Okay? Now, you look on the bottom there, I have 6, 50 degrees, or I have 6 with that less than extended, less than symbol with 50 in there. Essentially, those are the two ways that you will see polar form. How do I know I'm in polar form when I have this one looking at? Is because I see the degree symbol. That's not going positive 6 over and 50 up. That's going a 6 radius with a 50-degree turn. So essentially, I'm not saying that you won't ever see that, but for us, I am going to leave that out. I put that in there because the book states it. I wanted you guys to see that just in case. But for us, I'm going to use this notation here. And again, it's the radius on the outside and the what on the inside? The angle. So, how do I use this? How can I plot this? So, what it means is that everything's based off of the origin. I have some steps coming up. But those steps are, I start with an axis here, and I act like I'm standing at the origin. Okay? I stand at the origin. And the easiest thing for me to do first is to turn. It's less effort to turn first. And really what I'm doing is, this is not moving out yet. But I'd be looking, I'm going to change colors so that we can demonstrate this. I'd be looking at 0 degrees, which means I'm looking along the x-axis. Okay, that's standard position. Everybody's standing at 0 degrees, at the origin. And if I turn 50 degrees, am I turning up or am I turning down? Up. And I am going to start to turn my head in that direction, yes? Or my body. I'm going to turn my body 50 degrees. So at this point, I am looking in that direction, about 50 degrees. If you go more than 50 degrees, you have turned a circle and more. If I turn more than 300, I'd say 50, I'm at 360 degrees. If you turn more than 360 degrees, you made one full revolution. But you can keep going. You can turn as many times as you want. Okay, listen up. So I first, guys, watch this. I turn 50 degrees. So now I'm not facing the x-axis anymore. I'm facing some space between 0 and 90. Really close to half, right? At this point, I am going to move 6 steps out. I'm going to move a distance now of 6 in the way I am facing. So I walk out 6. There I am. And what you do is you put a 6 there. You put 50 here. Therefore, I turn 50 degrees and I walk straight out. Now, I'm going to demonstrate this by walking in front of the room. It's not going to be on the video, so I might as well pause it. So, to graph polar form, like I demonstrated in class, you start at the positive x-axis. I say rotate first. You're going to rotate. If the angle's positive, you move up. If it's negative, you're going to move backwards or down. And then you can walk out. Now, we only covered a positive one. Now, I'll demonstrate this again in front of the class. Is that if it's positive radius, you move forwards. If it's a negative radius, you are going to move backwards. Now, here's the problem. Or here's not the problem. Here's the thing that, really cool thing that happens. Technically, there's an infinite amount of answers or ways to get to the exact same spot. I can just keep rotating around and around and around. I'll keep hitting that spot, right? But essentially, we only like to stay within the 0 to 360 range. And so there are 4 different ways to get to one point in polar form. Between 360 to negative 360. So one rotation one way or the other. Because after that, you just keep rotating around and around and around. I'll demonstrate that in a second here. Obviously off film. Okay, so we've already graphed on the board, and let me see, and we graphed it already here, but here's the difference, guys. I just stated that there are 4 different ways to get to the exact same point. If I give you this form, 6 with 50 degrees, you don't have to get there 4 different ways. You follow those directions, that's this roadmap, you get there, you're done. The reason I showed you there were 4 different ways is because when we convert from one form to the other, then you will have to give all 4 methods because I'm requiring it. So again, we have our axes. You're going to turn 50 degrees and walk out 6. There's your point, right?
Why'd you start your arrow way down there?
You always have to start it on the x-axis. You always start your arrow on the x-axis because that is 0 degrees.
Why not the beginning of the x-axis? Yeah.
Not so I can see it. Okay, that's what you mean. I started out here. Yeah, because that arrow is just for you to say, I know I'm turning so far. It's to visualize it.
How do you know how far 50 degrees?
You know how far 50 degrees is because you know the whole thing's 90. Half of 90 is 45, so you should be a little bit more than half. If you need to, get a protractor out. Professional thingamajigger. So let's take a look at the second one, because that's the one we haven't done yet, is I can create the x and y axis. It's a little bit long on the x axis there. But how far am I turning? I'm turning a negative 250. So the good question is, how do I know how far negative 250 is? First of all, it's negative. I go backwards or down. So if I start on the x-axis and I go to here, how far is that? 90. That's 90. I go here, it's 180. We're not there yet. If I go one more, how far is that? 270. That went too far. By about how much? 20 degrees. So I can't do that all the way, so I have to stop about here. And if that's where I'm stopping, does that mean I walk that way? I'm facing that direction now, right? Here's the problem. It's a what kind of radius? It's a negative radius. So watch. This is what I'm going to do to help us out. I'm facing this direction, so it almost looks like I want to walk in that direction, right? 3. But I'm not walking in that direction. I'm walking backwards. 3. Because, now the reason I put the dotted line there is because the dotted line is the other half of the solid line going backwards. The radius is negative. We talked about that if the radius is negative, I go backwards. So I'm facing the dotted line, just to help us for a visual, but I walk backwards, or I extend it solid line backwards 3. And notice it changed from negative to positive.
So when would it be in the other 2 coordinates?
It won't be in the other 2 quadrants because that's not where the point is in space.
Ever?
Ever.
Because it's a negative, right?
Now, there's one more piece of information that I would like to highlight before we get into any kind of conversions. What would be another way to get to that point there? That's the type of things that you have to start asking yourself. Now, let's take a look. I just went a negative 250 degrees backwards. How could I get to that same point going forwards? How could I get to that same dotted line?
Double it.
Not double it. How many degrees are in a circle, guys? 360. If I went 250 backwards, how much would I have to go forward? 110. So if I went 110 degrees, let me move that. If I went 110 degrees, and then what would my radius have to be to get to the same spot? have to be negative 3 again.
Wait, what is this little less than thing?
Okay, guys, that's just a symbol to break the angle off from the radius. Guys, if I went 110 degrees, I'll change the colors for us. I'd be traveling in the red line to the dotted line. I'd be looking in that direction still, but I would have to move backwards. Yes?
Yeah. Where would you put the 3?
The negative 3 is out front again. So these are 2 different points.
On 0.
What do you mean, where do I put the 3? The 3 would still be in the same spot. What if I'm going to change the colors again. What if I wanted to go this way, a direct route? I just wanted to turn the shortest amount that I would have to turn and walk forward. So we know it'd be 3 because I have to walk forward, right? Because I'm going to turn negative. How far would that walk be? How far would the walk be so that I could walk straight out? Why do you say 50? No, it was 250, a negative 250 or 110. Guys, look at this. We said that if I started at the origin and went backwards, it'd be 250 degree turn, yes?
Yes.
How many degrees does it take to get to here?
10.
To the y-axis, or the x-axis again. Starting here, going around, how far is that?
180.
180. How much further did you go?
20.
We didn't go 20. How much further? You're telling me this is 180 degrees.
180.
This is 180, and all the way out to here is 250. What's the leftovers? What was there to get there? 70? So do you guys agree that that would be a 70-degree turn from the back end of the x-axis? So if this is 180, I turn another 70 degrees to get to there?
Yeah.
Now wait a minute. If that's 70, what's this angle over here?
30.
It's not 30.
30.
They're vertical angles, guys.
70.
They're 70. So this is 70 degrees. But since I'm going down, it's going to be
Negative.
negative 70 degrees.
Why is the 3 not negative?
The 3 is not negative because if I turn down 70 degrees, I can walk forward now. I can walk forward if I turn a negative 70 degrees. Now wait a minute, guys. What if I didn't want to walk backwards again, but I wanted to go all the way along around this way? How far would that be and still walk forward 3? Shouldn't be that hard because we already have the other part to finishing the circle. How far down did we go? 70. So if I went the other way, how far would I have to go? Not 70, the green line.
Wait, what's green on the big green?
The big, long green route all the way around.
290.
290. If I traveled 290 degrees in a positive direction, I'd be facing that dot. And to get there, I just move in a positive 3, or whatever, 3 feet, 3 meters to get to that dot. Guys, we just stated the 4 different ways to get, or 4 different ways, not the 4, but these are 4 different ways to get to the exact same dot without having to run past it. Because if I go another 360 degrees to any of these, I will have to pass that point to get back to it, right? So we stated all 4, or the 4 within negative 360 to positive 360. All of these have that option. So for tonight's homework, I would love to have done this, but we're not going to have enough time. So, your homework for next class is to, now you're going to have to leave yourself some room on this because you got other work to do with it. Maybe even on a separate sheet of paper. On your worksheet, number 1, so let's go to a blank page. Number 1, homework, day 1. Number 1, I want you to plot all problems. Two. So you're going to plot all the problems or graph them. That includes the polar ones and the rectangular. 2. On the polar form. On the polar form, I want you to find the other 3 forms. I want you to find the other 3 forms to get to that exact same spot like the very last problem we just did.